Continue from our previous video, we talked about estimation. So in statistics, estimation is a process using observation from a random sample to calculate the value of a population parameter. But the most important thing, after we did estimation, how could we know how accurate it is, how accurate they can represent the parameter in the population? So that's why we kind of want to know the variability of the estimation. So that's why from our demonstration from the previous video, here is our total compensation from the San Francisco city worker. So then we're using this one as the population. But usually, right, in the real life, usually we couldn't know the population. But here we just want to show you, when we do the estimation, then we really want to do is, if we could, we try to do more than one time the estimation. But according to the time and the money we have, we may not be able to do that. So that's why here we're only using one example. So we got the 400 sample. Then that's our kind of our random sample. So then from this 400 data, again, the same thing, we try to find the median for our sample. So that's why we compare. Here is the population median. So then here is our sample median. So that we call is the estimation, right? So then you can see here this estimation kind of like 5,000 different. So in the real world, we won't be able to keep going back to the population. Sometimes we only can do one sample data. So here, even we already we know the population median, so then we compare. But then, since we have limited time, limited money, how can we just do one-time population? Then we can be more accurate to find the parameter from the population. So how should we generate a new random sample without going back to the population? So that's why you can see, right, one sample, only one estimation. So then the random sample could have come out some differently. So how different will it be to when we get it again? So that's why we want to quantify our uncertainty. The estimation usually not exactly right, but how accurate the estimation is. Yeah, because if you don't have population data, you won't know. But if we have population data, then we don't need to do the sample, we just calculate the parameter from the population. So that's why here we want to know, we want to understand the variability of our estimate. Given the population, yeah, we can get data, but what we have is only one-time sample. So then, ideally, if we can get many value of the estimation, yeah, that will be more accurate, right? Because if we only have one estimate, but how about we have 10 estimates? Then we find the average. We have 100 estimates, we find the average. So definitely that will be something better than you only have one sample, one estimate, right? So get as many of estimation, kind of is a good idea. However, we cannot go back to sample that many times in real life. Why? We don't have money, we don't have time. That's why here we have a new idea. Yeah, you only have one sample data, you only can do one sample, that's fine. But let me show you a technique. From this sample data, we can do resample many times. So this one we call the bootstrap. What is the bootstrap? The bootstrap is a technique for simulating repeated random sampling. But all we have only one original sample. Just make sure this sample is large and random. So that's probably can resemble the population, right? So then we will create more sample, random sampling from this original sample. So that's what we talked about earlier. This is population, but this is what we couldn't get at. The only thing is we get from the one sample from this population. That's we get. But we all know only one sample data. You get one estimation. We are not sure how different this one can represent the population. So that's what we were thinking about. No, let's have more sampling. But don't wasting your time and the money. We just use this sample you already get. Then we do the resampling. So that's the bootstrap work. So the bootstrap is we only have one sample. Okay? Population is the value, the parameter we want to know. But for this one, for example, we say the size is 400 sampling. From this original sampling, bootstrap is we will do the resample according to this sample. So then we can repeat to do the resample many times. The most important thing is how we will do. Here, if the original sample size is 400, our resample is also 400. So remember, all the resample, their size is still 400. So then, no matter what, they will be still similar to population. But they have some error, they have some differences in there. However, since if we could get as many as resamples we have, then we just find the average from them. So maybe we can kind of balance out on the differences. So that's why we need our bootstrap. So how to do that? We don't know the population, but we have our original sample. So then we do the resample. So here we just treat our original sample as a population. We just keeping to rearrange or random drawing from this sample. So that's we have for our bootstrap principle. The bootstrap principle is when you do the resampling from the original random sample, they will be very similar to sampling from the population with high probability. But remember one thing, with reasonable for estimates many parameters from the population, the original random sample should be large enough and enough. So that's why here, when we do our resampling, since we have reliable and size large enough original sampling, so that's our resampling from the original random sample. They were similar to the we just sampling from the population again. So that's the key to do the resampling. The first thing, we need to make sure our original sample is large enough by random. Okay, so then according to this original sample, every time we do the resampling, we draw at random. And we replacement. On the other hand, that's me. In your resample, maybe they have some data they repeated, but that's okay. So as many value as the original sample, they will contain it. Why we need to do the replacement with replacement? Because one thing is, even we do the resampling, the size of the new sample has to be the same as the original one. So that's why these two estimations are comparable. That's why we can, according to that, all the resample to draw the empirical distribution. So that's the most important thing, how we will do the bootstrap process. So the first thing, of course, we have one random sample from unknown distribution. From this random sample, then we will do the bootstrap. How to do? The bootstrap will, according to the original sample, we treat the original sample as population. So that's why you see here the population, we quote on that and we use the red. because this one actually is not really the real life population. This one is just we treat our original sample is population. So that's why in our Python program we can do the sample portion. So then we can do the bootstrap resample, and also you can do as many as you want. So in this example we do 1000 times. So since you do the bootstrap resample 1000 times, then we can get 1000 estimation. So then according to that 1000 estimation, then we can have the estimate parameter in the empirical distribution. Okay, so then under some confidence level, then we can find the estimates is what we can trust. Yeah, so we talk about so much. Of course, let's see the demo will help you understand much better. Okay, so let's do our bootstrap. Also sample randomly. The first thing, that's using the original sample. Then we draw the same size of the original sample, but with replacement. Okay, so how we will do that? Also remember, earlier we have our sample. So this our sample is we create earlier. We using the sample size from 400 from the population. Okay, so that's our sample. So this our size 400 is our sampling. So it's our sample. So to make our bootstrap sample, actually we just need to do equal the original sample. Then we call sample function. So why? Because remember the sample function have two parameters. The first parameter is the size. The second parameter, you can tell them you want to do replacement or not. So since here we just using the size is everything. Also is the n. So that's why if you don't specify, they just take the n. So then with replacement actually is by default true. So that's why you don't need to have these two parameters. Okay, so either way they are fine. But I just want to show you both. So after you got that, okay, so then you have your new histogram. Now because this one is the new sample, right? So that's why you have one resample, that's your result. So that's our first bootstrap sample, resample. So then we need to find the median from our resample, right? So the same thing, we find the percentile 50 from our bootstrap sample. Okay, so then we see the data. Yeah, so that's 1000. Okay, so compared to before, a little more. Okay, but one thing is, yeah, that's the population parameter. But no matter what, you see, each time we do one random sample. According to that, we do one resample. But like we say, each sample just one estimate. So in order to have more estimate, then you see here, that's why we can write that into a function. Okay, so we define one bootstrap median. So from this function, we are not only do the resample one time, and we just return again that's total compensation. That's our 50 percentile, the median. So that's you were done in one function. Okay, so that's why when you run this one, each time you run one resample, they give you the median total compensation. Then you run more time. Okay, so you can see the range, right? 14,000, 140, more than 140. So this one, 138. Okay, so then this one under 130. So remember our population data is 135. But you can see here is, right, they do have each estimate, they have their difference, right? But they have their up and down. Okay, so don't you feel if we run enough time, then we just find the average, then they will be more close to the population parameter. So then we will continue to finish that in the next video.